So thank you very much for the introduction. It is a great honor that I've been invited today as panel speaker or as keynote speaker at this conference. You have already heard a lot about SRF qualities and about SRF utilization in the previous presentations. It is now my role in this series of presentations to provide you with technical aspects and the components of a state-of-the-art and modern SRF facility. I've kept my presentation on a basic, simple level with a lot of pictures so that everyone understands what are the components of a modern SRF facility. Before I start with the technical presentation, I'd like to give you a short information about my company, IoT. Yes. So, we are a small, independent consultant from Austria. We are just 11 people. We have been founded in 1999. We are located in Sebenstein, which is right between Vienna and Graz. Our focus lies on design and consultation services in the field of mechanical waste treatment. Our core market is definitely Austria, but we have done projects all over Europe. This slide shows the service portfolio of IoT. In general, we can follow projects from the early beginning, from the first idea, from the first concept, until the commissioning and handover to the client. In addition to the mentioned services, we do in Austria as well a lot of permitting for our clients. And our clients are not only from the waste management sector, but also from the industry. So let's jump into the topic of today. So, it does not work. Okay. What is the purpose of an SRF treatment process? It's basically very simple. It's the process to convert the input material to the requirements from the off-taker. You have heard already from Renato in this previous presentation that there are different aspects to be considered. So we have on one hand the physical properties, which are, from technical point of view, pretty easy to handle, because we can cut down the size to whatever grain size what is necessary by using shredders. We can separate foreign bodies, we can separate recyclables. In some projects, even thermal drying processes have been applied with recovered heat from the cement process to cut down the humidity of the SRF. The chemical process, on the other hand, are very difficult to be affected. We have limited technical possibilities to influence them. We can influence from technical point of view the chlorine content by using PVC separators so that we can cut down the chlorine content in the fuel. The other properties have to be as well influenced by sourcing of the input materials. That means if you have a potential input material which is showing improper chemical composition, you might not accept it as input material for your SRF production. So on this slide, I have put into the center orange box. Please consider it as black box for the time being. It is our job usually when we design an SRF production process that we fill this box with the required technology. For the selection of the equipment inside this box, we have more or less two main factors which we need to consider. We have on one side the input materials. I'm showing here different input material sources which can be utilized in an SRF production facility. They show a very big deviation. I will explain some of them. MSW, more or less a mixture of everything, can be very wet, can be very dirty, can also include as well a lot of recyclables, but the recyclables are not easy to be utilized because they're very dirty. In recycling processes, we want to have clean input materials. The commercial and industrial waste, so-called C&I waste, can be very clean, can be as well a mixture of different compositions, but especially if you consider industrial waste as input source for your SRF facility, it can be pretty easy to be transferred into RDF. Then we have sorting residues. Sorting residues are usually coming out of sorting plants. That means all the recyclables have been removed, and it's still a very valuable output material, the sorting residues, which can be converted into RDF or SRF. Bulky waste, on the other hand, is very difficult to handle. Everyone knows it from his home. When you have the collection of the bulky waste, you put everything out, from the furniture to the mattress and everything. So it's very inhomogeneous material which is very difficult to handle. Then we have rejects and other waste streams which might need different treatment plants as well, like tires or wood. On the second side, what is influencing our design, it's the off-taker. That means we have different facilities which can utilize RDF or SRF, and we will focus today on the main ones. That means today on the cement industry, on the input side, with these very inhomogeneous materials. One important message about this fuel production box, I call it black box, it's not a magical box. It is a mechanical treatment process, it's not a chemical treatment process. That means we have some limitations, what we can do. And the rest, what I said on the slide before, is we have to do with sourcing of materials. When it comes to a site, what components are necessary for a state-of-the-art SRF facility, here is an aerial view from an existing site to illustrate these necessary components. The main core process components are shown in bold letters on the side. That means when we design a facility, we need definitely property, we need roads, maybe for sure as well roads. We need a permit to operate our plant, to build our plant, and then there are the three key components. We need an input storage to store our incoming waste, we need a treatment process, and we need an output storage. The rest is infrastructure which is necessary for such a site. So the logistic system, weighbridge administration, social rooms, and so on, and safety system are completing the necessary installations. What you can also see very good on this picture, and it's maybe as well the first indication for this status quo for an SRF treatment process, is this arrangement of the buildings. We have separate compartments of the input storage, of the treatment area, and of the output storage, which is very important in terms of fire safety. I will come to that point later on once more. Now I will jump into these 4 bold segments, which means input storage, treatment process, output storage, and safety systems. So in the input storage, here I was showing some execution options, but the decision about which option can be taken is influenced by these factors which are listed. That means it can be regulations by law, which are very often go hand in hand with environmental aspects. We have input material quantities. If you have a lot of input material, it might be a driver to go for a closed building or for bunker building. The input storage capacity, which means how many days of delivery should be stored on your site. Then the input material conditions, loose or baled material. Baled material, you can also store it outside or in a shed building. It does not need a closed building, for instance. And then very important as well, for sure, your available footprint. So that means what is the space what you have available, because if you have a limited space, you should go maybe to a bunker system. If you have more space, you can go as well with a shed storage building. And as well, and I've discussed with a colleague from Lukovac yesterday in the bus, and very important is as well the location. If you are located right in the center of a city, you need to fulfill as well maybe some other requirements, which would need a closed building with a suction system and with that you have to take care about the smell what is coming out of the process. And then additionally, we have some automation of the system, which is well an influencing factor in safety aspects. Safety aspects, if you have some requirements that your staff should not get in contact with the waste, it should not get in contact with deliveries. If you want to avoid collisions of trucks and mobile equipment in the input storage, it could also be a driver, for instance, for a bunker system where you can limit these things. So this is generally the core of the process. We have a variety of treatment equipment available as designers or as plant designers from which we can choose. And this is really depending on the off-taker's requirement and the input material. And that's why, and then we are selecting the necessary equipment. For instance, we have here the shredders, which are always a core component of every SRF facility because this size limitation is a requirement for each cement plant. Then you can choose as well between 1 or 2-step shredding process. That's also depending on the input material what you have. When you have a very clean input material, you could also go for a 1-step shredding process, for instance. Then we have as well screens, metal separators to recover and remove iron, non-ferrous particles and batteries. We can reduce the PVC load in the fuel with PVC separators. We can separate heavy metallic parts or stones which could harm the process in a certain stage with a foreign part separator. And in addition, maybe in the future it will be necessary also to add, and we have some plants where these have been already added, is some equipment to recover additional recyclables. That means that you recover plastics, PET or something like that as well to fulfill maybe some requirements in the future regarding this recovery and recycling rates. It looks very simple, but as usual, the devil is in the detail and lies especially in the selection of the right equipment for your purpose and in the correct arrangement. The output storage is as well very similar. We have similar factors and options as for the input storage. I just want to highlight here some additional options. What you can have in an output storage is an automatic loading, unloading system or truck loading system. These are systems which can be applied and which are, I would say, as well in a lot of plants already state of the art. Safety systems. I think in the last years these have really become more and more important. I would put the focus here on the fire protection system. In the recent years in treatment facilities, due to the incoming material, which is also including batteries, several fire incidents have happened. And the industry or this recycling industry has also reacted on that. So it means the suppliers have developed special shredder guard systems, for instance, which are detecting the output stream of a shredder and are activating extinction nozzles. This is, I would say, really in each SRF facility more or less state of the art. There's a picture as well included here, which you can see a shredder and this location of sensors and nozzles. And as I already mentioned in one of my earliest slides, this separation of fire compartments is a very, very important factor which you need to consider. On top of that, you can always protect your building with sprinklers, with deluge systems, and so on. And and with heat release systems. But this is really a part where a state-of-the-art treatment facility is investing into. Then what I have not discussed, we have as well for the SRF facility different options. We can have it in an external location, or we can have it as on site of the fuel off-taker. For these two options, we have to consider different things. When we have an external location, I was showing here a picture of one of our clients. There's even a mountain in between, so they have to drive, I think, 70, 80 kilometers to be at the cement plant. You need to consider the logistics, and you need to consider as well the restrictions in the traffic. That means you need to build up the buffer systems at the off-taker site that you can cover as well these stoppages in the transport. If you are on the site of the off-taker, it's easier. You can connect your systems with belt conveyor systems, with pipe conveyor systems or whatever, and you just have to consider smaller buffers at the kiln. Here's an example how, for instance, an easier SRF treatment concept or such a system could be developed. That means I have drawn up here a scenario with simple so-called satellite treatment plants, which could be located, for example, on a landfill, and which are producing an SRF pre-fraction, which is then going to a maturation plant. And we can utilize as well mobile equipment for that, which is easy to operate as well on a landfill site where you do not have the necessary infrastructure to operate such machines. Yeah? These are diesel-operated machines. You can combine a shredder with a screen and with a wind shifter, and this equipment is available in mobile execution, so you can easily more or less implement such kind of installations on a site without infrastructure. One important aspect, if you consider such kind of installation on a landfill site, for instance, is that you have the big advantage that you can get rid of these rejects, which should not go into the SRF material. You can leave that directly on the airport, on the landfill. Yes, okay. I have also identified here a second type, for instance, which could be splitting and SRF plant. This could be especially interested when we are speaking about one-step shredding processes for sorting residues or for materials which are having less impurities inside, and they could deliver directly to the cement plant. So, status quo. I have to say the complexity of the treatment plant is generally, as I've already explained before, depending on the input material, on the requirements of the off-taker, and as well about the standard of waste management system in place. Yeah? If you have a source, for instance, a separately collected waste or the sorting residues available, then you can apply a much simpler SRF process. Then for sure all these regulations by law have to be observed, and they are heavily influencing as well the design of an SRF facility. The covered and closed input and output storage are as well state-of-the-art, especially driven in the European Union as well by this best available technology requirements. So that means this is also already state-of-the-art. And as I said before, the SRF facility can be moved to the premise of the off-taker or externally, and these fire protections are a very essential part for each SRF process. So, I'd like to thank you for attention, and I hope my descriptions have been valuable for you. Thank you very much.